Hello everyone, welcome to this video. Today in this video we will learn how to prove that product of the eigenvalues of a particular matrix is equal to determinant of the matrix, and if we calculate the sum of eigenvalues then it will be the trace of the matrix. Now for those students who don't know what it is the trace of this matrix, so trace is the sum of the diagonal elements of the matrix. So let us consider a 2 cross 2 matrix for this simple proof. So A is sort of A11, that is A12 that is B, A21 that is C, and A22 that is D. So what is the diagonal element? Diagonal element is those element in which the row number and column number are equal to each other. So this thing is in first row and first column, and this element D in second row and second column. So for these two elements, row number and column number are equal. It is A11 and it is A22. 1 equals 1, 2 equals 2. So that means A and D are the diagonal elements. So what is the trace of this matrix? So trace is sum of diagonal elements, that is A plus D. So A plus D. And what is the determinant of this matrix? Determinant of A equal to AD minus BC. So AD minus BC. What is eigenvalue? Eigenvalue are the solutions of this characteristic equation of this matrix. What is the characteristic equation of a particular matrix? That is determinant of A minus lambda I equal to 0. That is the characteristic equation. So what is A? At first we need to calculate A minus lambda I matrix. So what is A? A is basically A, B, C, D minus lambda times I. What is identity matrix? 1 0 0 1. So lambda times, so scalar multiplication, you know the scalar multiplication, every element of the matrix will be multiplied by that scalar. So lambda 0 0 and lambda. What is the resultant matrix? A minus lambda, B, C, and D minus lambda. Simple matrix subtraction. So determinant of A minus lambda I would be this into this minus this into this. So A minus lambda into D minus lambda minus BC. So what is the characteristic equation? A minus lambda I, determinant of A minus lambda I would be 0. So determinant of A minus lambda I would be equal to 0. So AD minus D lambda minus A lambda plus lambda square minus BC equal to 0. So lambda square minus A plus D times lambda plus AD minus BC equal to 0. It is the quadratic equation of the lambda. So what are the quadratic equation features? So there are two roots, lambda 1 and lambda 2. This equation has two solutions, lambda 1 and lambda 2, and the solution of the characteristic equation are known as the eigenvalue. So eigenvalues are lambda 1 and lambda 2. So sum of eigenvalue, sum is lambda 1 plus lambda 2. Sum is the coefficient of B minus coefficient of B by A minus coefficient of lambda divided by coefficient of lambda square. That is the rule for quadratic equation. So minus of minus, what is the equation coefficient? Minus A plus D divided by what is the coefficient of lambda square? 1. So 1. So A plus D. What is A plus D? A plus D is nothing but the trace. What is A plus D? A plus D nothing but the trace of the matrix. So trace of matrix C. And what is the product? Product is coefficient of the this constant term divided by coefficient of lambda square. What is constant term? AD minus BC. What is AD minus BC? Determinant of A. So sum of eigenvalue would be trace of the given matrix, and product of the eigenvalue, that is lambda 1 lambda 2, it will be the determinant of the matrix. So hence this is proved. I hope you understood this video well. Thank you for watching this video.